Hi everyone. So today we need to have a look at the importance of the research and monitoring that's going on in various different aspects around the world and the data that's being gathered. And we need to know, the spec says we need to know what's going on, an overview of what's going on, what's being collected, but also why is this important? Why is it so important that we collect data about what's going on? And this is obviously really vital in terms of planning for the future and mitigating against the potential damaging impacts of climate change. So we're going to have a look at some of the different measurements that are being taken, some of the different satellites that are being used by the big organisations to monitor things on a daily basis, on an hourly basis, and then on a longer scale as well. So the first example of a satellite is NASA's Earth Observing System, or EOS as they call it. And these satellites have been monitoring sea ice growth since 1978. And if you want to, you can have a click on that link and you can have a look in a bit more detail at what they do. But it's basically a satellite, so looking down on the ice sheet, and what they do is they record it. In particular, looking at September and looking at March. So looking at the maximum extent in the winter and the minimum extent of the ice sheet in September. And then they sort of run the sequence and they can compare year to year. So if you look at the bottom, you've got 1990 on the left, September 1990, March 1991. And then for comparison, you've got September 2018, March 2019. So you can see, particularly in the September image, in the minimum extent in the summer that the ice sheet gets to, you can see that September 2018 is much reduced. It's much smaller than it was in 1990. And this is used to show people, give people an illustration as to exactly what is happening, and you can see how much that ice sheet has shrunk. This is the second example. This is a satellite called Icesat 2, and if you can remember that as an actual example, if you can remember Icesat 2, that would be good. Now this is a little bit more complex. That previous satellite was really just giving us a 2D image of the ice sheet and the extent that it grew and shrunk to during the year. What this does is it actually uses technology and lasers to be able to look at the actual depth of the ice and to build up much more of a 3D picture of those ice sheets. Because it's all very well looking at the growth and shrinkage of the ice sheet, but that really doesn't give us a very much knowledge of the amount of ice that's being lost each year. And this 3D image here using the lasers gives us a much clearer picture into the mass of ice that is there year on year. Okay, now this is NOAA, so that stands for the National Oceanic and Atmospheric Administration. And they have satellites. This one here is looking at sea surface temperatures, or it gets abbreviated as SSTs, sea surface temperatures. And they are using radiation in order to measure the surface of the sea, the very top layer of the sea. And what they can then do is they can plot that onto a map like this one here, and like a choropleth map to show us the sea surface temperatures. And what it helps us to do really is to look at anomalies, so we can have a look and see those areas of upwelling and downwelling that are sort of out of the ordinary for their latitude. So for example, off the coast of southern South America, we can see that we've got that area there of downwelling, that we know we've got that exceptionally cold water there that's very, very nutrient rich, for example. So it enables us to look at patterns, but it also enables us to look at how sea surface temperatures are changing. So we've talked before about El Niño, La Niña. The first instance that we've got that is going to happen, it's going to be an El Niño year, it's going to be a La Niña year, is the sea surface temperature. So if we see that sea surface temperatures are warmer than average, then we're predicting it's going to be an El Nino year. If they're colder than average, then La Nina is likely. So it gives us a good indication of what's going on, but also to look at how those ocean currents are changing. So we've talked about how in the poles, with the extra melting water coming into the oceans, diluting the salinity, and then changing those currents that are then in motion. What we can do is have a look at how that's impacting upon the sea surface temperatures. And this is another NOAA satellite looking at water vapour this time. So this is looking at water vapour in the atmosphere. So looking at clouds, looking at the humidity of water vapour in the actual atmosphere. And then again, it's been plotted onto a map with a choropleth map. And we can see the much higher water vapour around the equator, as we know, and then much lower towards the poles. But again, it enables us to look for patterns, it enables us to look for anomalies, and it enables us to look for change to enable us to then predict and plan for the future. So this is a satellite that is used to look at deforestation, and this is a satellite that looks in particular at the albedo, or the reflectivity of the Earth's surface, and how land use changes can impact upon that. So again, there's a link there if you want to have a look at this in more detail. But what it's showing us really is deforestation. So when we run this satellite image over the years, so start in 1990 and run it all the way up to 2020, what we can then start to see is how has the reflectivity of the Earth's surface changed? How has the land use changed over that period? And what areas should we be concerned about? What areas should we be worried about? And then this is another NASA satellite that's measuring atmospheric CO2. So this is an orbiting satellite that is measuring not only the CO2 in the atmosphere, but also the effectiveness of the absorption of CO2 by plants. And again, this enables us to look at the pattern. It enables us to run this over a series of years and look at how things have changed. And it enables us to then also plan for the future. This is another NASA satellite looking at the primary production in oceans. So in particular, looking at phytoplankton and their prevalence and how that's changing in certain areas of the world. Obviously, the prevalence of phytoplankton is really important in the carbon cycle. The more there is, the more photosynthesis, the more carbon's being taken out of the atmosphere. So what is the point of having all of these satellites and measuring all of these things? It's really important for the future that we can have like an early warning system of what's going on. And if we're measuring a number of different variables, we can put all of that data together to give us a really clear picture of what's going on. And having big organisations like NASA and NOAA behind these satellites with their reputation means that we will have reliable, we will have accurate information. And the world leaders will only work with that. They will only work with data that they know to be real, that they know to be reliable. And actually getting anyone to put any mitigation strategies in place, you're going to have to prove that this is real. People are not going to be investing money in mitigation if they're not sure that it's really needed. So we need to have these reliable, accurate information sources. And obviously with climate changing, this is going to become more and more important as things start to change. So this is not in your work booklet, so you can add this in, add these extra notes in. So why is reliable and accurate data so important? It's important to give us a baseline. So where did we start? How have things changed? How have things deviated from that baseline? How has carbon increased? How much has it increased? How fast is it increasing? Should we be worried about this? Is there a link between carbon and temperature increase? Can we see relationships between any of these different variables? And that will allow us to then predict the future climate. And that will enable us to see how bad is it going to get? Where do we really need to mitigate against the impacts? What do we really need to do? And it will enable governments and international organisations to make decisions about these adaptations and mitigations that we'll need. And you need this data in order to make an informed decision, as we've just talked about. So it looks at lots of different indications. So land ice, but how does land ice then impact upon the sea level? What is the relationship? So with what volume of land ice does the sea level rise by 10 centimetres? So by looking at the relationship between those two things, you can see how land ice melting impacts the sea level. Looking at how cloud cover changing impacts plant growth, which then, how does that then impact carbon? So we can look at the complex relationships between each of those variables, and that will help us to plan for the future and what it is we need to do in terms of mitigation. This was just a summary from last year's International Panel on Climate Change, which is the big international organisation that looks at this. This was their special report from last year, and there were several key things that came out of that. In terms of climate change, the IPCC is the gold standard. This is the organisation that draws on all the best science. This is the organisation that the world's leaders look to, really. So what they'd said was, we're using too much land unsustainably. We are directly affecting global ice-free land surface, and all is impacted by climate change. Also, it was looking at the fact that we had a two-way interaction. Our use of land is driving climate change. As well as being an emission source, land is an emission sink. We know that because photosynthesis is taking carbon in. The global food system contributes 30% of human-induced greenhouse gas emissions. This was quite a big thing to come out of this report last year, the year before. So global food is a big issue. A lot of food emissions are unnecessary because there is so much waste in the global food system. We need to limit climate change, restore nature, and ensure food security. We need to do all three of those things at the same time, which is a challenge. And then it was also looking at the fact that sustainable land management is needed, and we need to fix the food system, we need to farm better, we need to improve consumption patterns and cut loss and waste. So those were the key things that came from the IPCC special report in 2019. You can have a look at this website here and have a look at the data set. So if you click on the data set gallery and have a look at some of the patterns, then you can start to analyse how patterns of temperature have varied and some of the anomalies around the world, and looking at some of the seasonal changes in chlorophyll in the oceans and ice thickness and things like that. This is a really good data source to just sort of have a play around with and have a look at what's happening. So these are the questions. I know some of you will have made notes as you've gone along in order to get those notes down.